In the last couple of videos, we've been talking about growth factor and decay factor. And if you go back and look at those notes, the factor, the growth or decay factor, is what you're multiplying by each time to kind of find out the population or whatever it is you're looking at over time. Now we're going to talk about what growth rate and decay rate is, which is a little different, okay? And so the factor is what you multiply by. The rate is actually the percent that it's growing by each time, or it could be the percent that it's decaying. What percent of whatever it is it gaining, or what percent is going away, okay? So now we're going to talk about how to look at the equation and find those two numbers, okay? So growth rate, there's a couple ways to think about it. But in the equation, the way to think about it is it's how much more than 1 the B is in your equation. And this will make sense once we start looking at it. But it's how much more the B is in your equation. Because another way that you can think about that B is you can think about it as a percentage. It's either going to be the percent that it's growing by or the percent that it's decaying by, okay? And so we'll talk about that in a minute. But if it's a growth, so you have to see if it's a growth first. So remember, a growth is when the B is bigger than 1, okay? Oh, you guys can't see that. So if the B is bigger than 1, that means it's going to be a growth, and so it'll have a growth rate to it, okay? So we're going to talk about how to find that. Something to do when you do this to help is if you change it to a percentage or change it to a percent, it'll help you think about it too. And if you do that, you can think about it, how much over 100% is it growing? Okay, so I'll show you how to do that too. So if you change it to a percent or a percentage, that'll work that way. And then the decay rate, remember, decay is when the B is between 0 and 1, okay? So if it's a decay, then what you're going to look for to find the rate is how much less than 1 the B is in the equation. Okay, so that's kind of looking at the other side of things, and that's going to look at how much of it's going away, okay? And again, if you change it to a percent or a percentage, it'll help you. So change it to a percent. And then that way, when you write your answer, it'll be correct as well, okay? So it is a rate. It's either the rate that it's growing or the rate that it's decaying, okay? So an easy question or an easy thing to think about, and just to get you started, is if something is decaying by 50% each time, that means that half of it is going away each time. So half of it, or 50%, would be going away. Okay, so that would be your decay rate. All right, so if it's growing by like 150% each time, that means that it's growing 100% and then an extra half on top of that, an extra 50% on top of that, okay? And so that's just kind of some real life, I guess, examples. But now we're going to look at the example or the equations and be able to tell the growth rate or the decay rate, okay? So when you look in an example or an equation, you're going to start by finding your B. So my B here is 1.11. And then you're going to ask yourself, is that a growth or a decay? So is this number bigger than 1 or between 0 and 1? And that number, 1.11, is bigger than 1. So that means it's going to have a growth rate. Okay, so now to find that, there's a couple ways to think about it. One, you can ask yourself, how much more than 1 is this number? Okay, so like you could take that and just look at it and say, okay, how much over 1 is that? And you could probably tell. Or if you can't figure that out, you could take that number and subtract 1 from it, and it'll tell you how much over 1 it is. So the growth rate would be 0.11, but you have to remember to change that to a percentage, because a rate is usually talked about as a percent. And so what is this as a percentage? All you have to do is take that number, 0.11, and you multiply it by 100, and it'll change it to a percentage. So the growth rate is 11%. So that means that whatever this is started out with 100 of them, and it's growing by 11% each time, okay? Now, what I was saying earlier is if you go ahead and change this to a percentage, so if you take that number and multiply it by 100 right off the bat, you'd get 111%. And you could think about, okay, well, how much over 100 is that? And that'll be your growth rate too, okay? So 2 ways to do it, all right? So let's do a couple more examples here. So what if you had this one? Well, find your b. The b is the number that's with the x as the exponent. So my b here is 1.35, okay? So is that a growth or a decay? Well, is that number bigger than 1 or between 0 and 1? Well, that number is bigger than 1. So that means it's going to have a growth rate. Okay, well, how much over 1 is that? So you could take that number, 1.35, and you could subtract 1. And so I get 0.35. So the growth rate, change that to a percentage, 0.35 times 100, that would be a 35% growth rate. It's growing 35% each time, okay? So there's going to be 35% more of whatever that is, okay? So it started with 200 of them, and it's growing by 35% each time, okay? So next one. Find the b. This one started out with 100 of whatever it is. And this one, the b is 0.88. So same story. Is that number bigger than 1 or between 0 and 1? That number is actually between 0 and 1. So that means there's a certain percentage of it that's going away. So there's 2 ways to think about this one. You can think about, okay, how much less than 1 is that number? Okay, so the way that you figure that out, if you can't figure it out just by thinking about it, is you would take 1 minus that number. Okay, so if I take 1 minus that, I get 0.12. Change that to a percentage. Okay, and so since it's a decay, it's going to have a decay rate. And so that means that it's actually decaying by 12%. So that means that 12% of whatever that is, whatever the population is, 12% of it is actually going away each year. And now the way to think about this number, if you think about that as like a percentage, that means that's the percentage that's actually staying from year to year, or it depends what you're looking at. It could be month to month, day to day. It just depends, you know, what X is. Okay, but this is the percentage that's staying each time. So 88% of whatever that is staying, but 12% of it is going away. Okay, so that's what decay means, is this is the percentage that's going away. And let's keep going. So let's do a couple more examples. So this one started out with 200, and the B is 0.94, or 0.94. So that number is between 0 and 1, so that means this is going to be decaying. So we're going to tell the decay rate, how fast is it decaying. So you're going to look at what percentage is going away. So if you think about it this way, 94% is staying, then how much is going away? You could actually figure it out pretty easily. So if 94% of it's going away, then that means 6%, or excuse me, if 94% of if 94% of it is staying, then 6% would be going away from time to time, okay? And now, again, just like I did in this problem, if you wanted to take 1 minus that number, you could get that answer as well, okay? So with decays and decay rate, it's actually easier for me to think about this is the percent that's staying, and then figuring out how much would be going away if that's the case, because that'd be the other side of the 100% to do that. But that's up to you, okay? So with this one, we started out with, if these were people, we started out with 50 people, and then we're multiplying by 0.81 each time. So that number is between 0 and 1, so that means the population would be decaying. So we just have to tell how fast it's decaying. So if, think about that like it's a percentage, if 81% is staying, that's the percent that's staying, then how much is going away? Well, you could figure that out in your head, or you could take 1 minus that number. And so when you do that, you've got, let's see, 1 minus 0.81, or you could take 100% minus 81%, and you get, that means that 19% of that is going away. Okay, couple more. This one started out with 50. The growth factor is 1.08. Okay, so that's a growth because it's bigger than 1. And so now we have to switch gears and we need to think about, okay, well, if it's growing, we have to figure out how much over 1 that number is. So this is where you take that number and you subtract 1, because you have to figure out how much over 1 that is. And so you get 0.08. Change that to a percentage. That means it's growing 8% each year. Okay. Last one, started out with 15 of whatever it is. My growth, or my factor, excuse me, because we don't know if it's a growth or a decay yet. My factor is 0.75, so that's the number that I'm multiplying by. That number is between 0 and 1, so that means that this one's decaying. So that's the decay factor. The decay rate would be how much under 1 that is. So this is the percent that's staying, so 75% is staying. What percent would be going away? Well, you could take 1 minus that number, and that means that 25% would be going away. Okay, so that's how you find the decay rate or the growth rate from the equation.